Students, in the previous session, we studied the classification of polynomials based on the terms and degrees of the polynomials. In this class, a special topic, that is general form of a polynomial. See, general form of the polynomial. P of x. What is P of x? Polynomial in variable x. P of x is equal to an x power n plus an minus 1 x power n minus 1 plus an minus 2 xn minus 2 so on a2 x2 plus a1 x power 1 plus a0, or we can write x power 0 also. X power 0 is equal to 1 into a0, a0. So, the last term is a0. In this polynomial or the general form of the polynomial, an minus 1, an minus 2, a2, a1, a0 are constants. X power n minus 1, x power n minus 2, so on x square, x power 1 are the variables in the polynomial, and that is one variable x. Is there any constraint in this form? Yes, that is an not equal to 0. An not equal to 0. An is the constant or the numerical coefficient of variables, and an not equal to 0. If you substitute an is equal to 0 in this general form, here the first term will vanish. We get an minus 1 x power n minus 1 etc. It is not the general form of the polynomial. Therefore, this is the general form and the condition is an not equal to 0. For example, P of x is equal to 4x minus 3. P of x is equal to 4x minus 3. P of x, it means x is the variable in the polynomial, and this is the example for binomial. One more, q of y is equal to 2y square plus 3y minus 9. This is the second example, 2y square plus 3y minus 9. There are three terms, so we can call it trinomial, and the polynomial in variable y, one variable y. Next example, r of u is equal to 1 by 4 u cube plus 6 u square plus u plus 8. 1 by 4 u cube plus 6 u square plus u plus 8. There are four terms, and the polynomial in one variable u. So, the polynomial is represented by r of u because u is the variable. Student, substituting the degree of polynomial in the general form. What is the general form? Yes, we already discussed. First, consider polynomial p of x is equal to x cube minus 2x square plus 3x plus 11. There are four terms, x cube minus 2x square plus 3x plus 11. 1 is the coefficient of x cube, minus 2 is the numerical coefficient of x square, plus 3 is the numerical coefficient of x, and 11 is the constant. What is the degree of this polynomial? What is the definition of the degree of polynomial? Yes, the highest power of the variable in the polynomial. What is the variable in this polynomial? Yes, x is the variable, and what is the highest power? 1, 2, 3. 3 is the highest power. So, what is the definition? Highest power in the variable, highest power of the variable in a polynomial. Polynomial is p of x, variable is x, so the highest power is 3. So, write n is equal to 3. N equal to 3 is the degree of the polynomial. Now, what to do? Yes, substitute the degree of the polynomial in the general form. Once again, the general form an x power n plus an minus 1 x power n minus 1 plus an minus 2 x power n minus 2, so on a2 x2 plus a1 x1 plus a0. Substitute n is equal to 3 in this general form. N is equal to 3. In place of n, substitute n equal to 3. Continue. A3 because n equal to 3, and next x power 3. Then plus an minus 1, an is equal to 3 minus 1, and x power 3 minus 1. Next plus n minus 2. What is n minus 2? 3 minus 2 and x 3 minus 2. Next n minus 3, that is 3 minus 3. After an minus 2 x n minus 2, we can write an minus 3 and x power n minus 3. 3 minus 3 x power 3 minus 3. We will stop here because when we get 3 minus 3, we'll stop. Next step, a3 x power 3. a3 minus 1 is equal to 2, and x power 3 minus 1 is also 2. Plus a3 minus 2, that is a1, and x power 3 minus 2 x power 1. Then the last term, that is a3 minus 3. a3 minus 3 is equal to 0, x power 0. a3 x3 plus a2 x power 2 plus a1 x power 1 plus a0 x power 0. But remember, x power 0 is always equal to 1. So, 1 into a power 0 only. Then we have the polynomial with the variable x. Compare the general form with the example, means polynomial. When we compare the polynomial with the general form or compare between two, we get a3 x power 3 x power cube. This is the first term. So, x power 3. What about the numerical coefficient of x cube? What is this? What is the constant? Yes, constant is 1. 1 x cube plus a2 x power 2, and the constant is minus 2 x power 2. Then a1 x power 1 plus 3x. Then last a0 x power 0. a0 means the last term, that is 11. So we get 1 x power cube minus 2x square plus 3x plus 11. Again compare, we get there are 4 constant. a3 equal to 1, a2 equal to minus 2, a1 equal to 3, and the last term a0 is equal to 11. Students, in the previous session we classified the polynomials into 3 types based on the terms. But we have one more type based on the degree of the polynomial. You know that the degree of the polynomial, yes. First, consider the first example, 5x plus 6. 5x plus 6 is the polynomial in one variable, that is x. So, we can say p of x or q of x or r of x is equal to 5x plus 6. What is the degree of this polynomial, or what is the definition? Yes, the highest power of the variable in a polynomial. The highest power of the variable in this polynomial is 1. So, we can say degree is 1. By considering the constants and variable in this polynomial, we can change the form of this polynomial into ax plus b. Ax plus b. We have written 5x plus 6 in the form ax plus b. Just compare the form with the example. A equal to 5, x is the variable and b is equal to 6. We can say a and b are the two constants in this polynomial. And there is one important condition, is that a not equal to 0. If a is equal to 0, or if you substitute a is equal to 0 in this form, we get 0 into x. The first term of this form will vanish. We get b as a constant only. So, we cannot substitute a equal to 0. What is the degree of this polynomial? Yes, that is 1. So, we can say the polynomial of degree is 1 called linear polynomial. Linear polynomial. Therefore, this is the general form of the linear polynomial, and one example, 5x plus 6. Second example, 2y plus 3 by 4. Compare with the general form ax plus b, a equal to 2 and b is equal to 3 by 4, and the variable is y. This is also an example for linear polynomial. Next, second example, 2x square minus 4x plus 5. There are 3 terms and the polynomial in variable 1. What is the degree of this polynomial? Degree is the highest power of the variable in the polynomial. Degree is 2. Degree is 2. We can write this example in the form ax square plus bx plus c. Right? Ax square plus bx plus c. Compare this form with the example ax square 2x square, bx and c is the constant, that is 5. What about a and b? A equal to plus 2 and b is equal to minus 4, not plus 4, because the form which is in positive, but the example which is in negative. So, we should write b is equal to minus 4. And the condition is a not equal to 0. Similarly, b not equal to 0. If a is equal to 0 in this polynomial, substitute a is equal to 0, the first term will vanish, we get bx plus c only. Bx plus c is the general form of linear polynomial. If you change a as b, we get bx plus its next letter, that is c, bx plus c. It will get the form of linear polynomial. Therefore, a is not equal to 0, b is not equal to 0. The degree of this polynomial is 2. So, this is the polynomial which is an example for quadratic polynomial. So, what is quadratic polynomial? 2, power is 2 or degree is 2 Therefore, the polynomial of degree 2 is called quadratic polynomial. Degree is 2 and the name or the type is quadratic polynomial. Quadratic polynomial. One more example, root 3 y square plus half y minus 4. Compare the general form. A equal to root 3 and B is equal to plus half and C is equal to minus 4, not plus 4, and the variable is y. The polynomial in variable y. Next, the last example, x cube plus 2x square minus 5x plus 6. How much terms are there in example? There are 4 terms and the polynomial in variable x. What is the degree of this polynomial? Highest power of the variable, that is 3. So, the degree is 3. We can write the example in the form a x cube plus b x square plus cx plus d. Cx plus d. A, B, C, D are the constants and the condition is A, B, C are not equal to 0. A not equal to 0, B not equal to 0, C not equal to 0. If A is equal to 0 in this polynomial, we get bx square plus cx plus d. Bx square plus cx plus d is the general form of quadratic polynomial. If you substitute b also 0, the first 2 terms will vanish, we get cx plus d. What about cx plus d? Cx plus d is the general form of linear polynomial. Therefore, the constraint is a not equal to 0, b not equal to 0, c not equal to 0. And the highest power is 3 of the variable and we call it degree is 3. Therefore, this is an example for cubic polynomial. Cube means 3. This is an example for cubic polynomial. So, what is the definition for cubic polynomial? State, yes, the polynomial of degree 3 is called cubic polynomial. Cubic polynomial. Okay students, in this class we discussed types, general form of the polynomial, and we compared the polynomial with the general form, and we classified polynomial into 3 types based on the degrees of the polynomial.